Hello and welcome. Today, we're diving into something big from NVIDIA. They've just laid out a vision that could completely change the game for our digital world, building a future where telecommunication networks are truly autonomous.
Just think about that for a second. What if a network didn't just follow orders, but could actually understand what you want it to do? A network that could predict problems before they happen and manage itself. That's the huge idea we're digging into, and trust me, it's way beyond what we typically call a smart network.
So to really wrap our heads around this, we have to get one thing straight: the difference between automation and autonomy. You see, automation is basically a script. It follows pre-programmed rules. If X happens, then do Y. But autonomy? That's a whole different level. It's about reasoning. It's about the network understanding an operator's goal and then figuring out the best way to get there, all on its own.
All right, here's the plan for today. We're going to start with why this big shift is even necessary. Then we'll look at the AI brain behind it all, how we teach that brain to think, and check out some practical blueprints for putting it to work. And finally, we'll see who's already using this stuff out in the real world. Okay, let's jump right in. The thing is, our communication networks have gotten so unbelievably complex that the old way of doing things, just automating simple tasks, it just isn't cutting it anymore. We need a fundamental leap forward to manage it all. And NVIDIA's big answer is something they call an agentic system. Now, don't think of this as just one giant AI. It's more like a team of specialized AI agents working together. They talk to each other to figure out problems, come up with solutions, and this is the really critical part. They test their ideas in a safe, simulated copy of the network before they do anything to the live system. So if you're going to build a system like that, well, it needs a brain. And this is it. It's called the NVIDIA Nemotron Large Telco model, or LTM for short.
And we're not talking about a small brain here. This model has 30 billion parameters. That massive scale is exactly what gives it the horsepower to understand the insane complexity of a modern telecom network. It's a real beast.
So what does this brain actually do? Well, because it's been trained specifically on telecom data, it literally speaks the language of network engineers. It can reason its way through tough problems, like figuring out the root cause of some obscure network fault. And a huge plus, it's open source. That means network operators can actually look under the hood for security and even fine-tune it with their own private data to make it even smarter.
Okay, so we've got this powerful brain, but how do you actually teach it to think like an expert? I mean, having a powerful AI is one thing, but getting it to solve real-world problems is the real challenge, right?
And this quote just nails the goal. NVIDIA teamed up with Tech Mahindra to release this open-source guide to do exactly that. The whole point isn't just to crunch data, it's to actually copy the decision-making skills of a seasoned network operations center engineer. So how's it done? Well, this playbook breaks it down pretty simply. First, you pinpoint the most common and critical problems your network faces. Then, you sit down with your best human experts and document exactly how they solve them. You take those solutions and create what are called reasoning traces, basically a step-by-step log of every single decision. And finally, you feed all those examples to the AI model. You're teaching it not just what to do, but the logic behind why it's the right move.
So we've got the brain, and we've got the playbook to teach it. Now let's look at the actual toolkits NVIDIA's giving everyone to put this intelligence into practice. These are the blueprints.
The first blueprint is a big one. It tackles one of the single biggest operational costs for any telecom company: energy consumption. The goal is pretty straightforward: use less power without ever degrading the service for customers.
And this is where that agentic system really shines. An AI agent is constantly analyzing network traffic. It then comes up with policies to power down parts of the 5G radio network when they're not busy. But, and here's that crucial step again, before any changes are made, those policies get tested in a simulation to prove they won't cause any problems for users. It's this perfect little loop of proposing, testing, and then safely deploying. All right, the second blueprint tackles another constant headache for operators: network configuration. Traditionally, managing all the thousands of settings that keep a network running smoothly has been a really manual and, frankly, error-prone job. But with this, an AI agent can look at the network, understand the operator's goal, like, say, optimize for super low latency, and then recommend the exact settings to make it happen. And of course, it tests them in that simulation first.
Now, this isn't just some far-off theory. This is happening right now. Let's take a look at how some of the big players in telecom are already putting these autonomous agents to work all over the world.
Over in Africa, Cassava Technologies is using this approach to manage its huge and really diverse network. They've actually deployed a team of 3 AI agents. One's job is to monitor and suggest changes, a second one actually makes the changes, and a third agent checks the impact and can roll it all back if needed. It's that AI team concept in action.
Meanwhile, in Japan, NTT Data is using an AI agent to handle a really critical problem, that massive surge of traffic you get after a network outage. The agent intelligently manages how and when to let users back on the network, turning what used to be a chaotic manual scramble into a completely controlled, data-driven process.
And check this out. Telenor Group is taking this technology to one of the most challenging places you can imagine, the open ocean. They're using the configuration blueprint to optimize 5G connectivity for their maritime customers, proving this whole system works even in the most dynamic and unpredictable conditions. So when you put it all together, the main takeaway is this. We are in the middle of a massive shift. For decades, networks have been these complicated beasts that needed constant human babysitting. Now, with these new AI tools, they're becoming truly intelligent systems that are capable of managing themselves.
This whole evolution from simple automation to true autonomy is already happening. And it leaves us with a really fascinating question to think about. As our digital world learns to run itself, what new, bigger challenges will we get to solve with our unique human expertise?